Today in the Developers Podcast, we're talking about data and specifically how to glue Panda with many AWS services. Thank you for downloading the AWS Developers Podcast. We're available in all good podcast applications, Spotify, Deezer, on YouTube as well, Apple Podcast. And you're more and more to listeners every week, every month. Thank you for that. Don't forget to subscribe so you receive the episodes every Friday morning. Today we are going to talk about data with two guests, Abdel and Anton. Abdel Jaidi, your senior application developer. Anton Kukushkin, your software engineers. You're both part of professional services based in the UK, in London. And you're the current maintainer of an open source project that attracted my attention a few weeks ago. It's called AWS SDK for Panda. It used to be called differently, but maybe you will explain the history of that as well. It used to be called AWS Wrangler. So if you listen us and you remember that open source project called AWS Wrangler, it's the same, SDK for Panda and Wrangler. Before diving into the specific of that project, I mentioned Panda a couple of times. It's a very popular Python library, but what is Panda?
Thanks for having us, Sebastian. Pandas is a very popular open source Python library, which is used for manipulating and analyzing data in data frames, which is a tabular format, basically. It is very common in the world of data in general and is used by data scientists, data engineers. I think it's downloaded about 300 million times every month.
Wow.
And it's
every month.
Every month. I think it's in the top 30 of most popular packages in the Python ecosystem. So it very much underpins a lot of the work that data scientists and data engineers do.
And yeah, if you ever wrote any type of code in Python that manipulates some kind of data, and I remember I did back at the time when I was doing some reporting with CSV file, Panda is like the Swiss Army knife of data manipulation with Python. And many of our customers, of course, use Panda if they are in the data part, data engineering, you said, but then they need to integrate the outputs or input for Panda with AWS service. And another Swiss Army knife, maybe, like the glue I said in the introduction between Panda and AWS services, is the AWS SDK for Panda.
That's correct. So AWS SDK for Pandas is the library that we look after, and the problem that we were trying to solve with it stems from a couple of realizations that we had about our customers, very much working backwards from the problem here. The first realization is that our users are heavy users of the Python library that I just mentioned, Pandas, so they use it for manipulating data and etc. And the second realization was that there is a big overlap between these users and users of AWS data and analytics services. So that's S3, Glue, Redshift, and the typical workloads that these users would have would be, for instance, reading partition data from Amazon S3 into a Pandas data frame, transforming it in a way, and then writing the results back into, say, a database such as Amazon Redshift.
Yeah, partition data is specifically hard to read manually if you have to write code for that. Partition data on S3 is when you split your file into subdirectories. I put quotes on directories because there is no concept of directories on S3, but like if you have a log file, for example, it's one directory for the year, then one for the month, one for the date, and then you have to aggregate all of that and navigate. So that's something that the library is doing automatically.
Exactly. So it really abstracts a lot of the effort that would go into doing this yourself. So that was really the real realization for us, was customers would write often this suboptimal code when it comes to interacting with Pandas and AWS. And it's time-consuming. It requires deep knowledge of the AWS platform. It's commonly referred to as undifferentiated heavy lifting.
I was exactly about to say that. That's exactly the type of things that everybody has to do. It's quite complex to do it right. Apparently it looks easy, but when you go into the details, it's difficult. and it doesn't bring any added value for customers. So I think this is the place where it really shines. It's to help customer to solve that and differentiate a layer. So what is this open source project? How does it work internally?
So the library basically exposes a collection of APIs to read from AWS service to a Pandas data frame, or write data from a data frame to AWS services.
So one of the two, the starting point is starting or ending point. It's the Pandas data frame. So it's data frame to a data-oriented AWS service. Maybe we are going to give a couple of examples, or from AWS to a Panda data frame.
Yes. So a data frame would be considered a first-class citizen in the library, with almost every API either starting or ending with a data frame. You mentioned examples, so the very popular one would be S3. So we have an API for reading Parquet data from S3 into a data frame. We have APIs for writing into Redshift. So if you want to do a copy command, there is you're starting with the data frame, we're going to store it into S3 first, and then copy the data into your Redshift cluster. These are the kind of abstractions that we are doing here with these APIs.
So it helps customer to save time, basically?
Pretty much.
Yeah, I'd say the main benefit is that it saves time on writing that quote-unquote glue code to get the data in and out of AWS in Pandas data frame format. It's incredibly easy. I think in most cases, I think it's just one function call away, and we have a very good breadth of services that we support right now. I think at this point it's 17 AWS services.
Wow.
S3, Athena, Glue.
Obviously S3.
Of course, yes. RDS, Dynamo, just to name a few.
Yeah.
Yep.
And DynamoDB, Redshift, TimeStream.
Some more niche ones like Neptune, Clean Rooms, Glue Data Quality. Some services that people don't use often, but they find the library very useful when they do need it.
So that's really the majority of the AWS data-oriented services. If you need to move data from an AWS service to code, to some Python code running in the cloud or running somewhere else, that's I look at the README this morning. As you said, it's most of the time it's one function call. Okay, there might be 5 or 6 parameters to the function call, but it's one function call to implement these quite complex operations, such as reading Parquet files, for example, and then moving them to Redshift. Yep.
And you're right, like just to mention like some of the complex scenarios that we abstract for our users. One common scenario that we see is writing partition data in S3, but at the same time updating the Glue catalog. So I think our APIs get interested when you're doing more than one thing, not just writing to S3, but also updating the Glue metadata catalog. That's a complex thing to do because you're calling two services. You need to store the data in S3, but then create a Glue table, update its metadata, update its column. The next time you're making the call, you're updating the table, not creating it. We handle all of these scenarios with the same API for you. All you have to do is supply the input parameters, and we will handle that under the hood for you.
And you start from a set of real customer use case. That's what I like as well. It was not you saying, okay, maybe that would be cool to have that. No, it's real customer problems that you have to solve as part of your professional services engagement. That's what I like with the libraries coming from your team, because they really answer to real customer feedback. A few weeks ago in the podcast, we talked about another library coming from professional service as well, that allows to orchestrate AI agents, and they start with the same customer challenge and say how we can scale that. Did you start this library, or you're not the maintainers of it?
So it was started by a colleague of ours who was in Brazil and has since left AWS for new pastures. But we have taken over a few months after he started the project and have been maintainer for the past few years.
The library is on GitHub/AWS, and of course the links are available in your podcast application. If you scroll down a bit, you will find the link and the documentation there. It's quite popular. You have a couple of numbers to share?
It is quite popular, I must say. The library is downloaded about 60 million times every month. To put things into context, because that doesn't tell you much when I say 60 million, but 1 in 5 Pandas downloads is driven by our library. In other words, every time someone is downloading the Pandas library, there is 1 in 5 chances that it has been done because they've downloaded our library, since it's a dependency of it.
When you talk about download per month, it's not user. I mean, a user might download multiple times. I'm thinking about CI/CD a scenario where every time the CI chain starts, there is a download. But still, the number is impressive. That's more than 1 billion downloads since the library exists.
Yes, and the library has been started in 2015, and we just passed the billion downloads milestone. I think when it's after a couple of years, we were at 1 million, so the growth has been very much exponential. And we're in the top 100 of most downloaded libraries in the Python ecosystem. So.
In the Python ecosystem, not talking about AWS.
Yeah, and I think it's also top 20, in top 20 most started projects in AWS GitHub organization.
So the message is, if you are managing data on AWS, in Python, that's most probably the case. You're most probably using Panda already. Don't write the glue code by yourself. Check the AWS SDK for Panda. Can you share a couple of examples of customers that are using this library? Any public reference?
Yeah, we have a number of customers that have been using the library, particularly some in ProServe engagements, since we have been involved in some of those and they have needed the library. And we've helped them with that. And I think what I appreciate about a lot of these interactions is that many of them would then contribute back to the library. There is something that they see that they want to improve, and they would open a pull request, and many of them would resolve it themselves, contribute back to the library. That has been fantastic for us to see. To give you a specific example, we've had customers create pull requests around Athena Iceberg and how to improve some of its functionality. It's always nice when it's the customer that is driving the roadmap, and we are just helping them along the way.
That's the power of open source, to have a code contribution as well. It's not only an AWS project, but anyone can contribute and can add code and help to improve or support their use cases.
Yes, we're open source and we're heavily community driven, so users can open issues on GitHub or pull requests. So if there is a missing feature, please do file us an issue on GitHub.
And I'm always saying that contributing to open source project is not only writing code. Not everybody is able or willing to write code, or maybe they cannot because of their company policy. But opening an issue or reporting feedback or contributing to the documentation, it's important as well. So don't hesitate to open an issue. We're going to talk about the project management and governance in a bit. But before that, what are the top use cases that you're seeing? We're talking about moving data from code to AWS or AWS to code, but can you give a couple of real life pipelines or example of how customers are using the library?
Yes, of course. So let's say I'm a data engineer and I'm assigned with transforming and ingesting data into my company's data lake or data warehouse. I can start locally in an IDE or a Jupyter notebook, install the library from Python package index or Conda. We do support both. And then I can draft the code, test it locally. Let's say I'm reading a JSON files, a batch of JSON files from S3, performing data transformations, for example, normalizing certain values, and either writing back to S3 to a partitioned Parquet dataset for efficient retrieval, or ingesting into Redshift data warehouse. Assuming I have AWS credentials set up on my computer, I can test it, and when ready to move it to an execution environment such as AWS Lambda. Now we also provide AWS Lambda layers for the library as well, so users can either select the AWS for SDK Pandas layer from the Lambda console or refer to it by the ARN.
So the typical developer experience happens inside a Juniper Python, a Juniper workbook, or it's more in an IDE on your local laptop? You're going to say it depends. I know what is the answer. Should not even ask the question. But it depends on what? The volume of the data? Preference?
I would say it depends more on the use case rather than the volume of data. A developer's needs are very different from that of a data scientist. Mm-hmm. So, yeah, it very much depends on what they intend to do with the data, and how are they using Pandas to do that. We see it won't come as a surprise, but data scientists are using a lot Jupyter notebooks rather than IDEs, and the other way around with your data engineers or where.
Okay, so it depends on the role data engineers to characterize, to simplify. I know there are exceptions, but data engineers would rather use an IDE, and data scientists more a notebook, a Juniper notebook, a Jupyter notebook. Sorry, why did I say Juniper? Maybe it's my background in networks or something. Jupyter notebook. You mentioned deploying on Lambda. Where customers are typically deploying the code they write with the SDK for Panda?
So we offer one thing that I want to say is that the library is platform agnostic. It can run on any Python environment, which could be a local machine, Jupyter Notebook, as Anshan has said, etc. However, when it comes to Lambda, we have created Lambda layers that are available to any customer in the AWS console. So if you go today as an AWS customer in the AWS console for Lambda, and you look for managed layer, you will find us in there as AWS SDK for Pandas. And that has been a huge driver in terms of popularity of the library. And to be completely honest with you, I'm not even sure people are attaching the layer to use our library. In many cases, it could be that they are just attaching it to use Pandas itself. Because if you go today and type in Google, how do I attach Pandas to a Lambda function, it is a very complicated process. And again, it's undifferentiated heavy lifting. It shouldn't be complicated to add Pandas to a Lambda function, but it is. And we have taken that work away from customer. We've abstracted it, and now it's as simple as attaching the layer to the Lambda function, and there you go. You have Pandas. You have our library as well if you want to use it. So that has been has made a big difference in terms of usage of the library.
I have a naive question because I'm not a data engineer, but I know, Abdel, you work a lot with Elastic MapReduce in the past. Is there a use case also to use Panda with Hadoop or with EMR cluster?
Less so, I would say, mostly because Pandas is single-threaded, and as you know, EMR and Hadoop, the whole point is that you want to. It's a distributed system.
Yeah.
Yes.
Okay.
And Pandas does not offer that, but we can discuss maybe later one thing that we've tried to achieve with Pandas to distribute it, which was a big project for us and has been challenging.
Yes, Pandas is great, but until you're processing petabytes of data, right? And yes, one of the things we've added to the library was support for distribution on Ray, so using Ray and Modin, which are open source.
What is Ray?
Ray is a distributed cluster compute software. It lets you distribute your Python code into a computational cluster environment.
And so now the SDK support deployment on Ray, so it means customer can split their deployment and run that in parallel on multiple machines?
That's right, yes. They can run this in parallel on multiple machines, and they can use the same data frame interface to do that. We use another library called Modin that runs on Ray to do that.
Is it supported in Panda, or you had to do some magic inside the SDK itself to twist Panda to do parallel processing?
Modin is a drop-in replacement for Pandas, so in most cases it mimics the APIs of the typical Pandas data frame. We did have to do a few things here and there, but in most cases Modin handled it for us.
So today it's supported in the library. Do you have customer providing feedback already about the feature? You have some real life experience of handling large volume of data in parallel with the SDK for Panda?
We have some customers who have been using it. The one thing that we should mention is that both Ray and Modin are still, I would say, incubating projects, as they are not as mature as we want them to be at this point. And also, this distribution does not cover all of our APIs. It covers a limited set of APIs that we offer within the library. And for those, we did see some traction from customers who are using them, particularly S3. Another interesting case has been DynamoDB, where if you want to distribute writes in DynamoDB, it can be a complex operation, and we've seen some customer use our library to do that.
Yeah, throttling DynamoDB to ensure that we don't hit the limit is retrying.
Exactly. So the retry logic. Mm-hmm. Yeah, the retry logic would be something that we would handle for you, so you don't have to worry about that.
So we mentioned several times that the project is on open source. It's available on github.com/AWS. We mentioned the benefits for customer, the benefits for you to be open source in terms of visibility and help you can get from the community as well. At AWS, we have multiple organizations on GitHub. We have AWS Samples, we have /AWS, we have AWS Labs, where we are incubating new project. The fact that you are on /AWS means it's an officially supported AWS package. What does that mean to be on the /AWS for you as a contributor and for customers?
So I think the usual kind of rule of thumb is that if it's in AWS Labs or AWS Samples, you're typically not supposed to put it into a production environment, while AWS is something that you are blessed to do so.
So AWS Labs for incubating projects /AWS, you can trust us. You can put that on. You can use this project on production. But what does it mean? That's for customer. But what does it mean for you?
The other thing I would say is that AWS Labs is for guidelines or patterns or architectures that you want to implement. Whereas if you look at the AWS organization in the company that we are with, it's a lot of SDK that have been battle tested. So you would find the official SDK for Python, Bojo 3. You would find the JavaScript SDK. So that's the kind of software that you would find in there. What it means for us is that what is asked from us in terms of SLAs, in terms of support, is slightly higher, I would say. So we have a mean time to first response metric that we track, which is we need to reply to a customer when they open an issue within 5 days. It doesn't necessarily mean that we will have a resolution, but at least we will acknowledge it and try to understand what is going on. When it comes to things like coverage of our tests, the bar is usually higher. So our coverage for the library is at 90%, for example. Another thing is when it comes to patching. So as soon as we detect that one of our dependencies, for instance, needs to be patched because there is a security issue or for whatever other reason, we're very quick into releasing a new version for our customers.
This means that you spend a lot more time looking at the issues, triaging them, and because some issues it's just a question or documentation point. It's not really a bug, so you spend more time on project management than on writing code.
We do spend a lot of time on that. That being said, we have invested heavily in automation, which you have to do when you have this volume of issues and pull requests. So for instance, whenever, let's say, an external contributor creates a pull request, and our entire test suite is gonna run automatically, and that has been fantastic for us because I'm based in London. Let's say the contributor is in LA. I would go to sleep. They would start their PR. Their entire test suite would run. I wake up in the morning. If everything is green,
You're
and
confident.
Anton and I had, and we're confident, and we can approve and merge immediately. It has happened to us that like it has been this quick. So yeah, my advice to anyone, to any developer looking into scaling their product is invest in automation as much as you can, because that makes your life much easier.
Yes, I'm a contributor myself on a large open source project, and we have the same large suite of tests with automatic run on each pull request, and that's super efficient to know the status of a contribution and the quality of a contribution. It doesn't prevent to look at the code and see if everything is correct, I thought, but we even check the formatting, the linting. It's not only the unit test or the integration test. I look at the project, and you have like 36 or 37 open issue, which is ridiculously small compared to the number of downloads and users that you announced before.
It is pretty small. As I said, we have that mean time to first response metric, and we're pretty diligent in ensuring that we meet it. So if you look actually at the number of closed pull requests or issues, it's in the thousands in there. So we're just like very, again, diligent to make sure
reactive.
Yeah, exactly.
You wanted to add something about automation?
More about like open source in general. One huge benefit I found of working in the open source, besides obviously being able to interact with customers, is interaction actually with other projects in the open source. So like I must stress that this library is like standing on the shoulders of other giants. So we use Bojo 3, we use Pyaro, Pandas obviously, and others. And just being able to open issues in other projects and collaborating with them to solve them, which has happened to us. Ray is another example where we have done that, has been very easy to do in the open source. It would be very difficult to do in the closed source. Another example is, even within AWS, there is one of our optional dependency is Redshift connector, which is another team within AWS which manages this connector for connecting to Redshift, basically. And many times someone would open an issue in our repo, and then we would just transfer it to them because they are the expert in that and they would know how to solve it. So that has been very good to do for us.
What did you learn while working on these projects? I know that as an open source project maintainer, we learn almost every day. We have challenge to solve on behalf of customer. What did you learn?
Personally, I learned how to scale a product. As I said, we started from a million downloads to 1 billion, and that like comes with its challenges when it comes to in terms of scale. So as I said, it has meant investing in automation. It has meant managing the team, so to prioritize some issues over others. It has meant investing in collecting metrics. We collect a number of metrics around the library to understand how it is being used, and that guides our roadmap. And to be honest, sometimes it has also meant making some tough decisions around what gets into the roadmap and what doesn't, because it's a question of making sure that we can deliver. So saying no sometimes has been a difficult thing to do, but an important thing to do.
I can add also, I think managing an open source project is a big responsibility. So, for example, keeping your dependencies up to date is very important, and we have to release frequent patches as well to update maybe vulnerable dependencies or the dependencies that contain some issues.
What is the future of the library? I know that we typically don't talk about roadmap for services, but here it's open source library. So what are the things that keep you awake at night?
Yeah, obviously AWS services are constantly evolving. Every reinvent, there's a bunch of exciting announcements. Like this last reinvent, they've announced S3 tables, and this is something that we're looking to put on our roadmap very soon. Obviously, we're always on the lookout for new big trends as well. It looks like, for example, transactional data catalogs in Apache Iceberg are getting more traction. Obviously, there's also new data frame libraries coming out. For example, there's Polars, and we're looking for things like those as well.
So, if I have to summarize, keep in sync with the ever-evolving S3 environment, new services, new functionalities inside services, but also with the industry evolution. You mentioned new type of data frame. You mentioned Iceberg as well. I think it's a big trend right now in data engineering. It's the Iceberg format.
Yeah. Yeah, and another very simple example of how a service has evolved has been Redshift Data API and RDS Data API. Before, you would need a GDBC connection, which is complicated to set up and doesn't follow the same typical flow that you would have in AWS of using an IAM role and Boto3 credentials and all of that. With Redshift Data API and RDS Data API has solved that, and that again is an example of an ask from customers saying like, "Hey, look. This exists now. Can you include it into the library?" Like as an anecdote, when S3 tables 2 days after it was announced, we already had an issue saying, "Can we please have this in the libraries?"
So your users are super reactive. You need to be as reactive as them.
Yeah.
Another example is Python 3.13 support on AWS. We were notified about that basically from I didn't know about it, and a user notified us, "Hey, Python 3 came out on the AWS. When are you going to support it?"
What do you mean Python 3 came out on AWS? You mean on Boto 3?
Python 13, sorry. Yeah, Python 13
version
on AWS Lambda.
On Lambda, yes, the runtime for Lambda, it's now supported. Going back to the HTTP API, just a minute for the listeners that don't know what it is. If I understand correctly, but you're the expert here, it's an HTTP REST API on top of RDS and Redshift. So as a developer, I don't need to use JDBC or ODBC. I can use a REST API. That's correct?
That's correct, but the other big advantage is that you only need to have an IAM. You can only use your IAM role to connect. You don't need to pass your actual credentials like you would do for a GDBC connection. So your IAM role would be sufficient to do that.
Yeah, and it simplifies the network connectivity as well, because most of the time Redshift RDS is inside private VPC, so having the HTTP as a public API makes it easier to access from Lambda, for example.
Exactly.
Or from my laptop. I don't need to do tunnels or complicated things like that. If you're serious about data in AWS, you probably know Python, you probably know Panda. Just have a look at the AWS SDK for Panda. That is the glue between the Panda world and the AWS world. And to talk about that today in the AWS Developers Podcast, we had Abdel Jaidi and Anton Kushkin, senior application developer, senior software engineer from Professional Services. Thank you, gentlemen, for your very clear explanation, and thank you for having listened to this episode until the end. Go check the links in the podcast notes. See you next week for another episode of the Developer Podcast. But now, go build.